Okay, so we are make sure when you open up Pearson, you are in grade 9 for the math units. If you're not sure where the math units are, click on this item over here, and then math will show up and ELA will show up. Click grade 9. This is the only option that you guys have for you guys, so it should be pretty easy to pick. Click on it and then click on Unit 6. Okay, this screen will open up, and then click here. And then we are going to skip just a little bit, and we're going to jump to completing the square. We did this one. We did lesson 2. We finished lesson 3. We're going to skip over this one for now, and we're probably going to come back to it if we have a little bit of time. Okay, but today, lesson 5. So if you go online to the Weebly, it'll say Unit 9. So on the Weebly, it's going to say Unit 9 because that's what we are as far as our units are concerned. For Pearson is Unit 6, so we'll say Unit 9, Lesson 5. Okay, that's what's going to be online on the Weebly. Okay, completing the square. So completing the square is really important in the title. We're going to make a square. That's really important, and it's going to look mathematical. It's going to be a mathematical square, and sometimes it will be a square, sometimes it needs to be made into a square. Okay, I know it sounds a little confusing, but once you see it, hopefully it'll get a little better. Okay, so slide number 1 says basketball notation. This is the opening. This is what it should look like. Okay, it says a basketball is thrown at a basket. The height h in meters of the ball is a function of the distance x to the basket. So basically what that is telling us is that we have an x and a y. This is x, distance, and this is y, or our h value, also called, in this case, h of x. We'll call this the height. Okay, and it's telling us the trajectory of the basketball. Okay, as the distance increases, the height goes up and the height comes down. Okay, and here's the equation of that basketball. Show that these two equations, in this green box, so we're going to start right here, show that these two equations, okay, so the equations are left and right, are the same. And it says I have to expand. That means I'm going to do this part, because this part where it says squared, I'm going to expand that portion. Okay, and then we're going to see if they're exactly the same. Okay. So let's open up a new page. We'll work on that first. Put this on a new page first. Okay, and we'll move this equation so we can see it on another page, nice and clear. Okay, so I want to prove that these two things are equal. I want to know that these two are the same. Okay, so here it is. Make it a little bigger, easier to see. Okay, so if you're not sure about your order of operations, because it can get tricky from time to time, let's keep this equation equal. I'll draw a nice blue river down the center. See, blue river. Okay, I want to make sure that this is the same as this. So what I'm going to do is I'm going to do order of operations, and exponents comes first. That means x minus 2 squared is x minus 2 times x minus 2. I'll multiply x times x squared, x times negative 2, negative 2x, and then negative 2 times x, negative 2x, and negative 2 times 2. Negative 2 is positive 4. I'll combine these two items together first, so that's my exponents before anything else. I'll have x squared minus 4x plus 4. That's still in parentheses only because there's a negative 1/2 in the beginning. This negative 1/2. At the end we have a plus 39, plus 3.9. Okay, so I'm going to distribute each one of these. I'm going to distribute, and distribute, and I'll have negative 1/2 x squared, and then positive, because negative times a negative is a positive 2 x and a negative times a positive is a negative, and 1/2 of 4 is 2. Okay, so the parentheses now go away, and I'm going to add this 3.9. Okay, so these two are my like terms. 3.9 minus 2 is going to be 1.9, and I'm going to bring everything else down. Negative 1/2 x squared plus 2x plus 1.9. Now I just did one side all at one time, and according to what I have here, they look like they're the same. Let me just bring it down. Negative 1/2 x squared plus 2x plus 1.9. Alright, these two are exactly the same. Okay, so that's what should be written on your iPad. Now I gave you guys a piece of paper in order for you guys to write things down by hand and then take a picture of it, because I know it's pretty tricky on this iPad. They're separated by slides. So slide 1, slide 2, slide 3. There should be enough space for you. Slide 1, you might have to write a little bit small because there is going to be a lot going on in this first slide. Okay, so we've done this. We've shown that these two equations are equal. So we did that. It says you will notice that the same quadratic equation may be written in standard form or vertex form. Vertex on the right, okay, standard on the left. Okay, this is standard form. We talked about this last class. Okay, now one method to finding the vertex of a quadratic is to use the completing the square method. Okay, that's what we're learning today. Okay, so we're learning completing the square method. Okay, this will allow you to take the standard form of a quadratic equation and rewrite it in its vertex form. So we went this time just now from vertex to standard. Today our goal is to go from standard to vertex. Okay, that's pretty tricky. We're gonna so here's an example on the right. We're gonna justify each step along the way, and more specifically steps 3 to 5. So steps 3 to 5. This part right here, 3 to 5, not this bottom portion. 3 to 5 is gonna represent completing the square. Okay, and we're going to talk about why it's called completing the square. Okay, so we're still on slide number 1. Okay, and what I did is I hit the button up here on the top right, the notebook. Okay, and we're filling this into slide 1. Now, if you run out of space, you can go ahead and spill over to slide number 2 a little bit if you need to. And I'm gonna move this over so we can see all the steps. I wrote all the steps in that last image out, and I spaced them out a little bit so that way we can write a little bit more and explain. Okay, so it says step number 1, and I needed to figure out what's happening from step number 1 to get to step number 2. Okay, now let's look at some fundamental changes. What's changing? It was a negative 1/2. Now it's not. It was a 2, and now it's a 4. Huh. And then we've got a 1.9, and then we've got a 3.8. Okay, so some things are changing, and let's figure out what that is. Now, the only numbers that really make sense to me really fast is when I look at this is this 2. From this 2 to this 4, it like doubles and then turns into a negative. Now, 1/2 and it goes away, it's actually making a 1. So 1/2 and 1/2 make 1. So it looks like this one is doubling, this one is doubling, and this one is doubling. Our goal is to have a leading coefficient of 1. That's what we want. Okay, so what we're going to do first is we're going to make this into a 1. Okay, so we're going to make our leading coefficient into a 1. So I'm going to make this into a 1. And I'm going to do that by multiplying it by a negative 2 over 1. Okay, the inverse. I want it to be positive 1. Okay, so I'm going to multiply everything. Okay, so I multiplied everything. I distributed that 2 And what you notice, to keep it equal, I had to multiply everything. That includes the other side of this equation, this 0 over here. So 0 times -2 still remains 0. This equation is completely equal. These two match, I'm good. Let's move on to the next step of the equation. Okay. Now I go from step 2 to step 3. Now this one's a little bit simpler, from 2 to 3. The only thing that changes is I have negative 3.8 over here, and it moves to the other side. It's no longer on the left side of the equation. It's on the right side. So that looks like additive inverse. So plus 3.8 to one side and plus 3.8 to the other. Combine those and we'll have x squared minus 4x equals 3.8. That matches down here. Now the reason why we do that is because, like the title says, we want to complete a square. What we're trying to do is we're trying to make this side of the equation, everything on the left side, we want to make this into a perfect square. And I'll explain that a little bit later. So I'm trying to make this into a perfect square. Okay. So what we're going to do is we're going to move the c value, move the c value or term to the other side. Okay. Okay, step 3 to 4. If you need to, pause the video, write it down. Okay. Step 3 to 4. Let's see what's happening. Now we see something completely new in step 3 to 4. We've got this 4. Now this 4 kind of comes out of nowhere. And let's explain where that comes from. This, remember we said completing the square, makes it a perfect square. What? Okay, now this is what we're going to do, and this is where it comes from. This 4 comes from this 4, but I don't just pull this number out. What I need to do is divide this number by 2. Okay, divide it by 2 and then square it. Okay, now let me repeat that again. We're going to take this -4, just this portion. Okay, we're going to divide it by 2 and square it. So we're going to take the b term, divide it by 2, and square it. Okay, now after we do that, we're going to add it to each side. Okay, because if I add it to one side, I have to add it to the other to keep it balanced. Okay, so this step is b divided by 2 squared. Okay, so let's write out the math real quick. -4 divided by 2 squared. Parentheses first, so that's going to be equal to -2. -4 divided by 2 is -2 squared. And that's going to be equal to 4. So I'm going to add 4 to one side, add 4 to the other. And what you'll notice is because we're squaring this, it's always going to be positive. We're always going to add a positive number to here. Now, this may be positive, but sometimes the number will, if this number on the right side is a very large negative, this side can still be negative. Okay, but we're always going to be adding a number. Okay, now that's step 3 to 4. Okay, I'm going to move down. If you need to, pause it, write it down, take a picture, whatever it is. Okay, now 4 to 5. Now remember I said here in step 3 we're going to make this into a perfect square. This right here is what we call a perfect square trinomial. Okay, let me write that down for you guys. This is a perfect square trinomial. Okay, now I'm going to continue this in the next video. The reason why I call this a perfect square trinomial is because this, when factored, I'm going to factor this Xbox method, okay, is going to create this item here. And this is a perfect square. Okay, I'll do the factoring on the next video.